Welcome to Playing with Junk. Today I'm playing with vintage computers. We have one Netfinity 5500 and we have one Netfinity X series 342 and these two machines go to scrap because the last maintenance contracts we had expired 2 years ago. No customer has these machines anymore, and by the way, this is a Pentium 2 machine and that one is a Pentium 3 machine. So even that, it's not even a Xeon processor. And yeah, maybe there are some collectors who say now, oh, what a pity, give it to me. But I cannot ship everything around the world and nobody will pay for the shipment, so I will take it apart. But first we turn it on, because we will not turn it on after we taken it apart. Let's start with the big machine. We have something that looks like a display, but that's not a display. We will see that later. There is a power button, a reset button, floppy drive and a large CD-ROM drive, and there is one disk. And we have space for 2, 3, 4, 5, 6 disks. Yeah, that's it. 6 hard drives for a machine of this size. That's not really a lot. Then on the back side we have a lot of metal. We have 7 PCI slots, but one is reserved for an ISA board. Integrated server administrator or something like that. We have one connector that looks like a phone connector. That's probably, it's possible that it has an internal modem. Then we have parallel port to serial port, VGA, serial management port that goes to the server management, remote manager, 2 USB, PS2 for keyboard and mouse, and 1 Ethernet connector. Then we have 2 power supplies, but when I shortly tested that machine, one power supply did a little bang and died. The other one is still good. And there is a main switch that is not a main switch. I will explain that in a moment. Okay, normally switches like this are mains switches. They turn off the power supply completely. Okay, there is an arrow. I have to plug in that. And I leave it on the off position. Let's turn to the other side. On this side we see a blinking green LED, which on IBM servers still today, or Lenovo servers, indicates that the server is on standby. So normally I would push the on button and it would turn on, but it doesn't. It just tells me that it is on standby. Okay, so let's turn that mains switch on and the server turns on, even if I didn't push the on button. And some additional lights turn on. We have a processor number 2. It's probably a bit hard to see. There is no green light for processor number 1 because we have 2 processors. I don't know what happened to processor 1. Maybe it's broken, maybe not. Okay, let's see if the screen tells us something. Okay, power on again. Still only one green LED for processor number 2. And at least we see it's a Pentium 2 with 450 MHz. We have 640K system memory that comes from the old DOS space memory, and we have 255 MB of extended memory. So in total 265 MB or a quarter of a gigabyte. Insane amount of memory. Okay, we got a configuration error. I assume that the Cmos battery is empty. We have RAID. There is one RAID controller, yes. I didn't see any drives. Probably because the drive is faulty. Power on password has become invalid. Okay. Configuration change. Okay, continue. Automatically reconfigure. Yes. Copyright 2000. Yes, already 20 years ago. Continue. Yes. I think load default settings is something that could help. Press enter, thank you. And exit setup. Save and exit, yes, okay. So all the settings are now on factory default. Should be or should not be any problem. Well, it still looks the same as before. It seems there is no more configuration error. Yeah, search for data. Vital product data, that's the serial number, that's diverse part numbers, and it collects that every time. And it tells us that it didn't find anything to boot, and we should enter a diskette into the diskette drive and then press F1. That's one of the standard I have not found anything to boot screens from IBM. Okay, it seems the disk is also broken, so let's take it apart. By the way, with the front cover off, we can see the indicator lights a little bit better. You see CPU 1 doesn't light, CPU 2 is green, power is green, disk no access, so it's not blinking. There's an OK button. Yes, it was blinking for 2 times. Yeah, there is 100 megabit link OK. That's for the integrated network card. 3 lights, as you know it. Normally they are on the back side. Here they are on the front. Okay, power off. And standby again. This time with the power supply powered on. Well, I don't get it why they made that strange switch, because it's not a power on off switch, it's a power supply standby switch on the back side. Very useful. What can we see here is we have 2 processors, we have 1 RAM module, we have 2 processor power converters called VRM, voltage regulator modules, and we have a lot of PCI slots with this strange plastic cards between the slots. And we have our hard disk bay here. We have a little speaker for the beeps, and we have error LEDs here for example CPU error, DASD, that's some error on the disk. There is no DASD2, they simply left away the LED, maybe because there is only one disk cage and no room for another one, and probably that LED would have lit all the time, so they desoldered it. There is a spare LED for that is not labeled. Memory, PCI 13 is also not available on this model. And then we have two fans here that blow air through this CPU cage. Normally there is an additional cover here. Let's look at the fans. They have individual cables. Let's put that away. And that's fan number 1, which is a radial fan, taking in air from the side, blowing it through these holes here in direction to the CPU. And that's the other fan, which is mounted a little bit lower in the case. So fan number 1 would be here, fan number 2 is here, and both take the air in through this hard disk drive cage. So hard disks are perfectly cooled. Cool air comes in from here, goes around, and where else? Well, through all these grids here. Well, there is not much airflow possible. Well, we have some holes here, but I think the main portion of air comes through this tiny little grid here and goes out to the big grid there. So I don't know how that works exactly, because the cover has no holes. Yeah, there are a lot of tiny little holes everywhere, but yeah, a little bit air goes between the drives here. So yeah, it works, but it's probably not the best thermal solution. But on the other hand, the processors from that time didn't get that hot. They had large heat sinks, but a relatively low number of watts. So let's take that out. So that's the Pentium 2 processor in its slot version. Pentium 3 came also in this slot version, but also in a LGA version, or no, it was not LGA, it was, well, a square pin version. We will see that in the other server. I don't know how that is called, in fact. Relatively large heatsink, so that one stays cool for a long time. The other one, however, has another mechanical trick to remove. So we have two different kinds of processors. It has this blue strap here, and it seems that is original IBM, because that's a typical IBM color for all kind of buttons and levers and stuff. It's also a Pentium 2, and it should be the same as the black one here. Maybe we can see the numbers here. Don't know, I can't read it, but it must be 450 megahertz. So let's put them to the side. Let's talk about this strange plastic walls here. They are between the PCI slots. You can see the slot connector here. So the PCI card goes between these plastic covers, walls, whatever. You may think that's for airflow. No, that's for electrical insulation, because this machine is equipped with hot swap PCI. So that's the red levers here. Hot swap PCI means you can change, you can remove and put in cards while the server is working, while it is hot. So hot swap. They thought in the late 1990s, early 2000, that was a cool idea to have hot swap PCI, because if anything breaks, you can remove it while the server is working. You don't have to shut the server down. So that's what the salesmen say. Then people like me came and asked, well, but what kind of card can you actually hot swap? Because if you have a RAID controller, you cannot hot swap it, because if your RAID controller fails, your system is down anyway. So you have to reboot it, you have to change the RAID controller, you have to configure the RAID controller before the system can be booted. So RAID controllers doesn't work. How about graphic cards? Well, first of all, nobody uses graphics cards in a server. Well, maybe today, yes, but in those days you simply used the internal VGA port, and that's also something you cannot change, because you cannot change the whole mainboard while the server is running. You could change a network card if one fails. That, by the way, that works like if you're using Windows, like removing a USB key. There is a button, safely remove hardware, and instead of only USB keys and external drives, there is also your PCI card listed. So of course you need the appropriate driver for all that stuff. And then, if that works, you open the red tab here. And as soon as you lift the black tab up, there is a contact here in this plastic. You can see there is a cable attached to it. So this senses that you opened the PCI door, or however they call it. And then you have here two light guides that go down to two LEDs on the board. Maybe we can see that. Yes, I think that's the LEDs, the light guides, and then it turns green, or I don't know if it extinguishes, I'm not sure about that. It's quite a while since I saw one of these things working. And then when the light goes off and you told the software to turn everything off, you can actually remove your board. And then you put the new board in, close the black tab, close the orange tab, that also locks the card in place. And then the board realizes that everything is closed and it powers up the slot here again. And now the plastic protection insulators here are simply when you take out the card and you touch one of the other cards which are fully powered, you could destroy the server. You could short it out or just crash it, or well, and that is to prevent that one card touches the other while removing when the server is working. Hot swap PCI. Good idea, but totally useless. So that's the reason why they gave it up a couple of years later. So that lasted for probably 3 or maybe 5 years, and then servers came without hot swap PCI because nobody really needed it. Okay, what kind of crappy drive do we have here? IBM 9.1 gigabyte, or shall I say gigabytes? According to Dr. Brown, that's the correct pronunciation for that. Made in Hungary. Yes. October 1999. Well, let's talk about service friendliness. You may think this entire CPU cage here could be lifted out when we remove that 4 screws. And to be honest, I thought that too, but it's not true. So we remove these 4 screws with the appropriate tool and always use a cup for the screws so they won't get lost. And you can spill it all over the place. Okay, so all 4 screws are opened. We could release, yes, but no. And if we look closely, we can see that big white connector for power is of course attached to a cable that goes down into the machine, and we have to unplug that first. But unplugging that cable is not so easy because there is this plastic shroud here. I already removed the fans, but that doesn't give any way to this connector. So I assume I have to remove the whole hard disk enclosure here to get to that connector. Okay, let's see if that's true. No, there's also no way through the connector to this back plane. I have to remove it. And probably now you understand why I scrap certain machines instead of selling them, because they really deserved death. Yes, that's my opinion. And if somebody really wants to work with a machine like that, there are certainly some of them on eBay or wherever. Of course, I have to unplug SCSI connector, power connector, to remove this board. There's quite some stuff on this backplane. That's where the 6 disk drives go in, with the large SCSI SCA connector, single connector architecture. And most of this stuff is for controlling the environment. Is it too hot? Is it too cold? And of course to activate the LEDs here, 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 here and here. Quite a lot of stuff. And of course there are some additional cards that could be plugged in here. You also can add another SCSI connector that goes to the next disk bay. Okay, that's that. And now we can actually see this large white connector, which is now unpluggable. It's unpluggable. That means you cannot plug it, or you can unplug it. Okay, but there's still another connector there, a black one, behind this voltage regulator module. And that connector can be accessed maybe through that hole here. You can see it down there, but in fact it's is a bit difficult. I need both hands. Okay. Okay, that was not so easy. And now I should be able to finally lift that out. Okay, yes, that's it. 2 connectors. Stupid. And here is the rest of the main board. We can see the big connectors going to that CPU module for 1 or 2 CPUs. Then we have, what's that? 0 power snap-hat lithium. That's the clock, the internal Cmos Clock. And there's another weird chip that looks like it has a battery. By the way, snap-hat means you can remove that battery pack from the chip. You see, that's a chip, that's the contacts for the battery. Come on, focus please. And that's the battery. So this is developed from the old Dallas chips that had its battery inside the chip when the battery died, but that only died after 15 to 20 years or so. But when the battery died, you had to replace the entire chip. And here in this case, you can replace that battery module, which is of course extra expensive because it's specially made for that chip. But in case of an emergency, you could also connect any battery to these ports. You only need 2 of them. I don't know, I think that one is, no, that can't be. Well, there's certainly a data sheet where you could figure out how that works. And then you connect your 3-volt lithium coin cell to the correct 2 pins here. You only need 2, so they are made in a way so you can snap this battery on this way or this way, it doesn't matter. Is that right? Yes, it looks, no, it has a pin, it has here, come on, it has here an extra pin, so you can't put it on upside down. But I don't see where that extra pin is actually going on the chip. Oh yes, it goes here. There's a hole, there is no hole, so that way. Okay, I could also measure that chip here. I'm pretty sure there are a couple of volts left, and then I know where plus and minus is. Or I simply look at it. No, it's not written. Okay. So that chip here is something different, and I think normally I use a screwdriver for that. It's a little bit more gentle, and that's just a pin, a chip with a lot of bent pins. That's what I did just now. And this one has the battery inside. And if that one is dead, you need to replace the entire chip. Also an example of bad design or bad repairability. So let's see where that black cable that comes from this phone jack goes to the main board. Here, to this white connector. Don't know. I don't see the usual circuitry for modem, so I think it's something else, maybe another kind of serial port or whatever. Well, doesn't look like USB, Okay, and we also have a standard coin cell here for, well, if that one was, I don't know, maybe for some settings, don't know. They have 3 battery type storage for all kind of stuff. Okay, then we have here, what's that? Looks like SCSI. Yes, is SCSI. Goes down here, and is not connected. Okay, nothing connected except the terminator here. Every SCSI bus needs a terminator on each end, so you need one terminator on the cable end, and the terminator here is shiny plastic, that chip here, most likely, yes, because all the SCSI lines go to this. That's an active terminator chip. And then here is the SCSI chip, Adaptec, typical SCSI interface chip. There's another terminator chip because we have a second SCSI bus, this time with a blue cable or blue-gray cable, and that was the cable that went to the disk backplane. On this side it has a bit of different connector. Here it has the typical 68-pin white SCSI 16-bit connector, and that one too. So that's an integrated SCSI card with 2 SCSI ports, each supporting SCSI wide up to 15 drives, 16 including the controller, but the controller address is already occupied. And we have here another flat gray cable that goes to the front here, which drives the front panel here, LEDs, buttons. It also goes over to this LED panel here, and then floppy connector goes here. Okay, that's it. And why is this machine so big? Because we have huge power supplies. Looks like a spaceship. We are docking into the space bay number 2. Oops, my camera is too big. Okay, power supply has a safety screw, has a big handle. Oh, it's still on. Turn it off. And it's not that heavy, but it's big. So question is, how many watts? It has made in Italy. Yes, that's always the best for electric things. Italians may be wonderful people, but electric things, that's not their business. Okay, there are no watts. Okay, 3.4 volt, 15 amps, 5 volt, 25 amps. You can count all that together. Oh, here it is, 400 watt. So that's a 400 watt server power supply. Yeah, it's not much bigger than a PC power supply, standard size, maybe a little bit longer. But we have 2 for redundancy, and that in the other hand, on the other hand, means the entire server cannot use more than 400 watts because it must run with 1 power supply. Okay, I think that's it from the big one. Let's see what the smaller IBM server does. That's the IBM x342, and we start on the back side. We have 1, 2, 3, 4, 5 PCI slots, while 1 slot is occupied by this strange card, which also has Ethernet and probably a modem, and this time it also has an external power connector. That's the remote server management, and this power connector has the purpose you can attach an external power supply. So if the whole server dies, has no more power, nothing, and this card is still powered to the external power supply, you can access the card and at least you can see what happened with the server. You can check the log files and see there is no power and you have to do something, but you have a connection still. Most users don't use that external power feature because if the server has no more power, then either two power supplies are faulty or the entire server room is dark, so both situations are not so good. You have to do something anyway. We have two serial ports, PS2 ports, network 1. Then we have two network ports, first USB of course, 2. We have two network ports for an ISMA and B, integrated server management. We also have a management serial port, monitor, VGA and PCI 1 to 5. And no power switches. This machine is a little bit more modern. We can also see that here. VGA port is already blue, according to the blue of the connector, because on the first PCs and server everything was black. Connectors were black, sockets were black, and you had to look where you put your stuff in. Today everything is color coded, wonderful for your young people to play with. Front side, power button, powers up. We have one disk and space for two more disks, and behind this grid here you can see the power supplies, two at the time. Then we can remove the front. There's a little button here and we just rip that away so you can see the button. That's the model number, and that's two power supplies with some LEDs that tell you, for example, hard disk, warning, we already have a warning, power supplies, both green, AC and DC, power on LED, button, reset, floppy, CD-ROM, yes, works. It's a same type of CD-ROM as you have on a laptop. Okay, let's see what it does. Okay, post errors, bad Cmos battery. Yes, of course, that server was in stock for a couple of years. That battery went empty. Power on password has become invalid. That's the same message as we got from the other server. No problem. We don't need that password. And I say continue, automatically reconfigure. Yes, it's the same menu, but we are in 2004 now. The other server was 2000. Continue. I do the same, load default settings. And of course, if I would try to use this server, I would of course replace the Cmos battery. There are also some servers that don't even start up when the Cmos battery is empty. Some show you a red warning light, some simply don't work, you never know. So if you have a server that doesn't work, doesn't power up, you probably check the Cmos battery quick, because yeah. And we have a newer generation, it's now an eServer. The older one was a Netfinity, now it's E. It resembles at the letter AT that you use for email, because, well, internet was still relatively young in this time, and everything that was connected to the internet had an at, or in this case an E with a circle around. And by the way, iMac also came out in these years. That actually means Internet Mac, and we have a working Windows. That's a good disk. Still working. Yes, iMac means Internet Mac, because the very first iMac, these colored bubbles that look like sugar candy, they were made to make it easy for people to get into the internet. They had a built-in modem, they had all the software, and it was relatively easy to configure all the software, in opposite to some Windows machines from that time. And yeah, I also had one, and I discovered the internet with that. So iMac, eServer, whatever. Press Ctrl-Alt-Delete to log into Windows 2000, built on NT technology. That means on new technology. Because that was the first Windows. NT was the first Windows that was not Windows 95 or Windows 3.11. They said they wrote a totally new kernel and called it NT, new technology. And this one uses new technology. Okay, first problem, mouse does not work and keyboard does not work. That's because that's the first time USB keyboard and USB mouse is connected to this server, and it was configured for a PS2 keyboard and mouse, and now it has to load drivers and reconfigure itself for USB. That takes a while. While mouse and keyboard drivers are still loading, let's have a look inside. I already opened the top case or the top cover, and we can see another funny detail. We have power connectors here on the back. They go through this box, which is probably a line filter. I hope so. I hope it's not only an empty box. Then power cables continue here, go up here, and end here at the power supplies. And power supplies, I think I should be able to remove one without crashing the server, have a standard connector here, and there is another standard connector up here. So they made a 230 volt, or in America 115 volt power bus that goes from the back side to the front side. Well, yes, why not? Normally you would install the power supplies on the back side and then you don't need cables like that. Well, they decided other ways. They said, we want the power supply in the front, so everyone can simply change that or replace that, and then we are left with 3 disks, but that's enough. Okay, why not? But we have space for 2 more CD drives, or maybe a large tape drive or something like that. We have 2 fans with handles that can be just plugged out, and if I do that, you hear the other fans turn faster. We have another fan on the back here. That one pushes air in, that pulls the air out, and we have small fans on the CPU heatsink. So the problem is, why? because you have here a large fan blowing air through this air duct, which is covered by the top cover. We have another large fan here, which draws all the air from here out, which is in this case makes no sense because this air here is still cool. The other half, you can probably see that, gets half of the air here and then a little bit of the air from the top. So I don't know if that makes a large difference. The problem is that's relatively small fans, and relatively small fans fail quite often. So the other problem is here you have redundancy. If one of these fans fails, you still have airflow. If that fan fails, it just blows through. If that fan fails, it just sucks the air through, no problem. If one of these fails, you certainly get an alarm telling you that one of the CPU fans is off. Probably it doesn't make a large difference because I don't think that this small fan puts any additional air in, because we already have an airflow here underneath that. I don't know. But anyway, these are single fans, and if one of them fails and the CPU actually overheats, well, the server will stop before that happens. Okay, by the way, that's a Pentium 3 and they are quite interesting to operate without a heatsink. Okay, let's see. Do we have a mouse now? No. Last time I tried it, it worked fine with an USB keyboard and an USB mouse. But this time it doesn't get it. So I could, of course, connect a PS2 keyboard and mouse, but I don't want to. So I do this. So you have seen Windows 2000 working. Let's turn it off. Yes, that's it. Okay, let's try an experiment. What happens with the CPU when I remove the CPU coolers? These guys. Well, I'm disappointed a little bit because I expected this Pentium 3 to be the type with no heat spreader. Heat spreader, that's that metal plate on top here. This one has gray or white thermal paste. The other one has the typical original IBM thermal paste, which is probably good when it's new, but it's extremely sticky sometimes when it's old. It's like a wax that just sticks between the CPU and the heatsink and makes it sometimes almost impossible to remove the heatsink on old machines. There are Pentium 3 processors that didn't have the heatsink, so you only saw the bare die here, upside down of course. You saw the back side of the die, not all the funny nice transistors and stuff. And the contact area was only from the die to a little bit of heat thermal paste to the heatsink. So the die was probably 1 by 1 centimeter. And if those were operated without the heatsink, they exploded within seconds. Smoke came out and the CPU was dead because there was absolutely no thermal mass to heat up. It was only the die itself with nothing around it. And here we already have a heat spreader. That's a piece of copper that has the die underneath, soldered to it with low temperature solder. And this heat spreader alone is already a tiny little heatsink, of course. Anyway, let's see what happens when we turn it on. We have all fans here. No, we don't have the CPU fans. Okay, anyway, Power on. We have 2 red lights. Meaning that the 2 CPU fans are faulty, of course. We get something on the screen. So that means Pentium 3, 1.3 gigahertz installed memory. Okay, let's keep an eye on that. Too bad I don't have my thermal camera here. There is no sign on the screen telling me that anything is wrong. Okay. Server works normally. Finds a hard disk. Starting to boot Windows. Okay, no problem. Starting Windows. No bubbles, no smoke. Interesting. I wouldn't dare to touch them now because they are certainly 100 degrees or more. And when I say degrees, I mean centigrades, not that Fahrenheit rubbish. Okay. Still not blowing up. Now, server turned off. This could mean 2 things. One, CPUs died, or server has recognized that CPUs are too hot. Should I touch it? Yes, they are pretty hot. I would say 70-80 degrees, but not extremely hot. So this has a better or a more liquid thermal compound. Don't know. Let's turn it on again. Turns on again. So I'm a little bit disappointed. No fireworks. Okay. Let's see if it's still working. Yeah, still working. So that means that's already a better type of processor that has a temperature sensor and that has a good enough thermal mass to not overheat immediately. So it takes a while. And it's of course only Pentium 3, so it doesn't have that much power. Okay, I think that's enough. I smell some smell here, so it's certainly getting hot. Speaking of power, where is the power? 135 watts maximum. No, that cannot be total power. There, total power 263 watts. Okay, that's plausible. So that means this server must run on one power supply, so it cannot use more than 263 watts. So that is more or less a 250 watt power supply. The other one too, but you cannot add the power because it must run on one power supply alone. Okay, what else do we have? We have RAM. They look pretty normal, except for they have 2 slots here, and they are 128 megabyte. Yes, and I think that's the other 128, because in old servers you have to install memory in pairs, equal pairs. Where is it? Yes, 128. And that one is also, no, that's something else. What is that? Oh, that's 512. So we have 2 times 512, that makes 1 gigabyte, and that's a quarter gigabyte together, so we have 1.25 gigabyte of RAM. CPU, oh, already cooled down a bit, only 50 degrees. Has a lever here. Cannot be opened without tools. Okay, it can. And that's the type of socket I meant. So I don't know how much power this actual CPU uses. I think maybe 20 watts, something like that, maybe less, because it took quite a while to overheat. Okay, that's also the voltage regulators for the CPU. There's another fan. PCI, battery, we have Adaptec SCSI controllers, ServerWorks, that's the chip that does everything with, I think, serial, parallel and floppy. SCSI cable here goes from the backplane to the backplane of the disk, from the main board, and that's the server management card with another SnapHat chip here, battery, this time in yellow, so you find it a little bit better. Maybe it's a newer version, but it's exactly the same thing here. Maybe they are even compatible. Yes, they have the same pins. Yeah, probably same shit in yellow. We have special chips here. So that's the server management card. With help of this card you can power on and off, or you can power on the server and put it off into standby through that cable, and here also all the signals from the server. If the server is okay, everything goes to that card, is then transferred into a web page. It has a little small web server here. You connect Ethernet here with give it an IP address and connect to it, and then you can manage the server. Sometimes even with a remote console that lets you remote control the entire server. Okay, I hope you find that interesting. And that's the last picture of that server, and it goes to scrap tomorrow. Thanks for watching.